So welcome everybody to my session. Uh, since we are in a track about next generation PDF, I can promise you that we will learn something more. Uh, Maybe for those of you who are here for DAF's presentation, you already are familiar with the derivation term. I'm Roman Toda. I'm software engineer. I work with on a PDF libraries, products, services for over 20 years, which means that I witnessed the evolution of PDF as a format, evolution of our market, and let me introduce you a little bit to how I see the PDF evolved over those years and what is the most relevant for us today. So PDF was introduced to the world like 25 years ago, and with the basic idea how to interpret page on a device. So we started purely with the graphical model. We defined provisions in the PDF for accurate rendering on a screen or on a paper. Later on, as PDF evolved or started to evolve, we introduced marked content. So we needed to know a little bit more about structures in a PDF. We needed to know what is a paragraph, what is a image, and so on, what is a table. And the evolution didn't stop there. We introduced the whole mechanism of tagged PDF. And also, with the tagged PDF and PDF UA as a side corner of this, we introduce a different model to interpret PDF to the world. It's not just rendering now. We need to present PDFs through assistive technologies to blind people, for example. They don't know what, or they can't read what's on a paper. So we need another way. We needed another way to present the content to them. So it's not only about the precise layout anymore. It's more about the information the author wants to present to the consumer. And consumer could be anyone, could be a person, could be a system, search engine, whatever. So today we are facing some problems, as Duff mentioned earlier in the presentation. We don't know how to precisely or how to efficiently use PDFs on a mobile, in the browsers. That model we developed, that page model we developed 25 years ago, isn't enough. And we have problems with PDFs in automated processes. Like if you have one part of the sentence on page one, another part of the sentence on a page two. Our current processes don't join them into one sentence. So if you try to search for occurrences, they are not really tied together if they are not properly interpreted or tagged. So we have to question right now the biggest strength the PDF market sees in a PDF, and that's the precise layout. That's the best implementation we think there is. These days, HTML rules the world. People access content from their mobiles, from their tablets, and that's mainly in a PDF, in a HTML form. And to be honest, customers don't care that much. Customers that are consuming on the mobiles, if the color is interpreted precisely. What they need is just the content they want to access, right? And we, as developers, are always asked to provide solutions for, just give me that PDF in a different format. Give me back my Word document from that PDF. And that where export comes into a game. Developers like myself try to come up with the best ways how to export data from PDF, even though they are not properly structured. We are coming up with heuristics and we are trying to do our best to convert the structure and semantic out of the PDF, even though the PDF isn't prepared for that extraction, right? So we have two different ways how to interpret PDF right now. Even rendering, that's the precise layout. That's how you take an element from a PDF, you paint it on a white canvas, on a paper, and that's it. Or you're trying to come up with your own heuristics. You're trying to detect tables, for example. You're trying to detect lists and trying to discover the hidden meaning behind those lines and glyphs and images that are painted on a canvas. And what are the options right now? If we look at the world, how it's, or the PDF, how it's structured right now, and how the PDF, what provisions PDF gives you, we don't really have that many options to actually do something about it. Obviously, we can provide alternates in a PDF. We can provide attached files, embedded files, associated files. That's the modern term in PDF ISO 32000-2. So yes, if someone wants access their Word document from a PDF, the author has to attach it. That's easy, right? We can also provide alternate representation, but now for a specific device. But now, what's device? Actually, is it a mobile? Is it the difference between Android and iPhone? So maybe we could talk about media or landscape portrait. Maybe there is a mode as well that plays a role. So what if we can represent or interpret PDF differently than just rendering? And Duff touched this already a little bit. There are options, and we believe that there are possibilities how to do that. We don't need just to render a PDF on a device, on a page, on a paper. We can consume the PDF differently, but it has to be properly used. So we came up with this new word, so to speak. It's derivation. Derivation would be our new word for rendering in concept of this presentation, and maybe even looking further in the whole concept of the next generation PDF. So the question is it possible to deterministically, unambiguously interpret PDF content in a web-based environment? Do we have all the information in the PDF that are necessary for us to do this derivation from PDF into an HTML? And yet we believe we do. Actually, tagged PDF, as they are described in ISO 32000-2, they provide us very powerful language to do this. And now it's going to be a little bit more technical. I will try to dive a little deeper into what actually is the current concept of tagged PDF files. So bear with me, please. Right now, as it stands in PDF on the right side, I have a screenshot of a PDF I prepared for you. And on the right side, you have a rendered PDF, rendered page. On the left side, you have a structure tree. That's an entity that we know from PDF world, and that's where the magic of tagged PDF happens. So we, or author, or authoring application, is able to, via this structure tree, prepare and better description of the page itself, not just graphical operators, and you paint something here and then you take a glyph here and put it here, but what is the real meaning of the PDF file? So if you look at the text as the document is structured, you have the H1, which actually says we have an header or heading 1, and it's imaging model. That's the real content in a PDF file. If we look closer at a couple of structures here, we can see that even lists are very well defined. I have a list, I have list item, I have a body, and this is all in a PDF language, as well as table. Table does have contains rows, so we have a language how to precisely describe the structure, the semantic of a file. And actually the language is pretty rich. If we look at the ISO 32002, we have a lot of standard tag types or standard structure element types, to be precise. And all those structure element types are very well defined. And if you look at those closely, many of those sound very familiar to you if you know HTML tags, like for example div, span, paragraph, and so obviously some are a little harder to imagine, like for example annotations. The annotation model is a little different to what we know from PDF and similar if you look at the HTML representation, but we believe we can deal with that. So let's have a look closer how it's written in a PDF file. So every tag does have a type. That's the S attribute in a dictionary, and also does have like a pointer into PDF page content. That's the K1, which actually points into a content page. And you see the close connection between content and tag. And then obviously you have in content written the text that's painted on a page. And that's where when we do proper derivation or when we do an extraction, that's where the actual text comes from. Obviously, it's not that easy. You have to run that through all your 2 Unicode mapping, stuff like that. But for the sake of presentation, this is just enough, right? And then maybe if we can interpret all those informations I just gave you, we would be able pretty easily to derive this PDF structure into an HTML. Yeah, H1 maps to H1, text maps to span. I can even take language from structure tree, from tag element, and this is how we think things might go. And let's have a closer look at how that would look like in the HTML output. It's there. It's not really fancy, is it? It's not blue. So let's have a look how we can fix this. And yeah, obviously we can try also another different tags or different structures. Here we have list, for example. In a PDF structure we have L list item, L body, and you do easy derivation. And as you do the derivation into HTML, you look how the output will look like. And yeah, you can notice the problem there, right? It's in here. And whose fault is this? That's the question. Best practice guide that's been written, or we have several best practice guides for making PDF UA files or tagged files. But those say or tell you how to write good tagged PDF files. And they would say that this is actually not the best way to describe list. This is one of the good ways, for example. So you distinguish L body and label here. One of those. But it's not that easy, obviously. You can also use this one. So you marked up the marker of the list as an artifact. Maybe author doesn't want me to know what type of marker do I use. It could be dash, it could be whatever. If author thinks that it's not important, the visual appearance of that marker, they might decide mark it as an artifact very easily. Could be a little harder. What to do with this? And now, with this example, we are facing, it's pretty similar example, right? With your eyes, you can see that our marker is option 1, option 2, option 3. In this particular example, we would have not list, but ordered list. But our tools today are not really good with this. So yeah, this, with most of the tools that are on the market, would not be properly tagged. So there is a need for better tooling to do better tagged PDF files, as well as this one. There is a figure image there. I'm not aware of any tool that would tag this list properly. Maybe they are. I'm not aware of those. So let's have a look at another example which is a little bit different. Now let's have a look at table. Obviously, table does have a structure that's written, or that's kind of based on common sense. You have a table row, you have a header, and you have cell marked, right? Every cell could have one or more paragraphs. In this case, CC, ITT, fax decode, that's just one paragraph, but it could be more. That's all good. If we run this through a just obvious derivation, it will look something like this, right? So table would be derived from PDF into HTML into something like this. We have direct connection between tags in PDF and HTML in this case. So let's have a look how this would look like in output. Yeah, table is there, doesn't look nice. Maybe you can't even recognize it's a table. Something is missing here, and that's the styling, obviously. The question now is what to do with styling. This is a table from PDF 32000-2 that describes all the attributes or all the attribute owners you can use on a tag. Attributes is set of parameters, set of attributes you can apply on each tag, right? And the attribute might be of a specific kind. In this case, we call that owner. And there's a lot of owners, a lot of domains of attributes you can apply on a specific tag. Let's have a look how these would apply in a real world. Text element, if I have a tag on a specific tag, I can have a dictionary where these attributes are. So you can see O, layout. If I go back, layout is one of the most common use attribute owner set of attributes. And there are other attributes like start indent, text indent, space before, and so on. These attributes are describing a little better the tag itself. They are giving the tag a little bit of meaning. But if you look at the table on the right side, you might see that there is actually more than one attribute dictionary on that tag. That's because you want to apply not just one owner, but you want to apply two of those. So we have a owner of table and then owner of layout, right? So there is a concept. There are provisions in a PDF right now that allows you to better define the tag and maybe add additional information that might be helpful. Let's see how. Oh, one more step back. PDF contains another provisions that helps you to enrich your capabilities of describing the PDF. And they're called role map and class maps. They are defined on the whole document, and there are basically two maps, right? One, a role map. As you can see, type of this tag is Kommentartext. Is it good in German? Okay. It's not a standard type, right? It looks like someone came up with this word. And also the class, I don't apply attributes on this tag right now, but I use C. I said I want to apply on this tag attributes of this specific class. It's very helpful if you have specific language you use or specific class sheet, I would say. I'm not worried about the word. Then you may apply this list, and through the class map you may say I want this tag to be of this specific class and of this specific type, and then obviously every type of the structure element has to point at the end of the standard structure element type. In this case, that would be P paragraph. Okay, so you just only using your own language of describing. But at the end of the day, you always the processor has always know what exact type it is, and the type has to be deterministically described. And we're coming from the PDF 2.0, and that's the language that's there. Okay, the similar goes into with the class map. I can use my class map, and you see every tag that would use this standard class would then be obviously tied with this set of attributes. Okay, let's have a look at a table of attributes, again, attribute owners again. And we see that with ISO 32000-2, we have a little more options there. And creators of ISO 32000-2 came up with a lot more. We can call it namespaces if you wanted to, although namespaces are used for different things in PDF. But we definitely, all those attribute owners are familiar to us from HTML world. And we will specifically look at the CSS that we can use right now. And it's quite obvious that we may apply the similar types of attributes on a tag. So let's have a look how that would look in the real world. Let's apply these attributes of type of CSS 3.0, font size 32 pixels, text align center, color blue, background color yellow. How this that look when we are running derivation on this? Yeah, derivation, we can apply styles. They can go directly from the attributes or class map if we wanted to. And we would derive HTML, and as an output, it would look like something like this. Okay? Not exactly the same as it looks in PDF, but if that's what our author wants, maybe that's not that bad. How would that look if I apply class map? It's a little bit different. In here, we did have attributes on a specific tag. That's when inline styling applies. But if we use class map, we have a better language to describe this. We can use or we can generate CSS along the way. So if we have a class map, we will generate something like this on the right side, and I'll show you this on a table that is in there. And close inspection is that it's very straightforward. The derivation between attributes into an HTML CSS style sheet is straightforward. You can use it directly. And then if you go through derivation of the structure tree, and if you go to a content, if you go to a tag, that does have this class map applied, you would just use class in your derivation, right? And the table, the derivation of the table, table tags is pretty much the same. You just recognize that the tag is using specific class map, you apply it, you prepare that it upfront before the derivation runs, because the class map is processed before, and you kind of come up with this at the end, right? So that looks a little nicer now. By saying this, I wanted to point out that the PDF does have a very rich language by which you can use to actually describe the PDF semantic and structure very precisely. On the other side, you also do have the control over the appearance if you wanted to. In some circumstances, it doesn't really matter, the appearance. So if you run well-tagged PDF through derivation, we will end up with HTML file. And it doesn't have to be just HTML file, but in our next generation PDF, we are concentrating on HTML purely in the document. But let's step out of this concept and think about a little bit about future, about the world in 20 years. Would HTML be still valid? Maybe there are other formats out there that we don't know yet. We believe that if you have information about the structure in a PDF, then the derivation into anything could be possible. Maybe not that easy, maybe not that straightforward, but definitely you need those informations about structure, about tags, about things like what the table, what data are behind the table, and so on and so on. Yeah. Let's move a little farther. What if we want to use our own company style sheet? Would it be hard to actually apply that style sheet on our PDF we are producing? You may ask, as a creator or as an author of documents, do I really need to apply hard code, all the attributes on each tag, or come up with a class map? Couldn't that be easier? Yes, it could actually. Associated file, that's an answer that lies in PDF, PDF 2.0, and you may apply any associated file on any tag. Let's imagine this scenario when you apply your associated file on a high-level tag somewhere, and that associated file is CSS, right? So tag element contains an array of associated files with just one item currently, and that goes directly into an HTML as a reference. And for my own testing purposes, I downloaded a couple of different style sheets from different websites just randomly. In this case, I used Mozilla's. By applying Mozilla's style sheet, obviously I do have those attributes directly which overrides the style sheet on specific tags. But with Mozilla's, with WebKit's style sheet, default style sheet, the document will look something like this. If I run the derivation, the same file with just another associated file on it, just different style sheet, it looks differently. If I take Microsoft's style sheet and just download it from Microsoft's site, it looks completely different. That by saying that, or showing this, I wanted to tell that you as an author do have control over the appearance or over the process of derivation algorithm, and still you are providing the very same information there. By very same information, I mean the same data, right? Appearance is different, but that's your own choice. How would you style the document? I took Adobe's. That looks actually nicer. I don't know why. I also use Stack Overflow's style sheet. And you can see they decided for whatever reason that heading 1 should be aligned on right. Okay. And this is the default one, yeah, the Mozilla's one. So very easy change. And you might have different results, but as I mentioned, full control is in your hands. Is it easy? Not really, not that easy. There are, as mentioned in the very beginning, there are things that people would, or you as a creator of the document, can use easier or derive easier than others. There are things that I didn't cover in these presentations, things like metadata, destinations, for example. We know the concept of destinations in PDF. How would those be translated or derived into an HTML? Would not be that direct. Annotations, as I mentioned, area roles. That's another concept that's been introduced in PDF 2.0 or another provisions or language. That is pretty similar to what is in HTML, and this could be easy. On the other side, MathML, SVG, as Duff mentioned, there are languages, or there is a language, there are provisions we can use from ISO 30002. We can use associated file on specific tag that would be used during the derivation when deriving document with MathML, for example. Yeah, so I don't have that much time to show you all the cases. I just wanted to point out that might not be easy, but that's the way we decided to go. Forms, another big topic. Some of the work on forms has been already done, some not really yet. But we're working on that, and we believe that when it comes to a derivation, and if you have proper tags, then you are actually good to go. And as a summary, I wanted to highlight that the world of single representation of the PDF is over. It's been over for a while. We just didn't realize it, right? Blind people simply are not seeing. They don't see advantage of the precise representation of a content on a page, right? They need different way how to access the document, how to consume the content. And so this idea is around for a while. We just expanding the idea of not having just one single representation of a specific PDF document. We believe that it's time to explore the possibilities of having even multiple representations of the same content. If we are consuming documents on devices that don't have any display right now, they could be very low resolutions, they could be whatever, right? We can't really send PDFs there, but we would need to access those files there, at least the content of those files. And this is unified way how to do that. And along the lines, you might hear tag PDF, that's the provisions we need to go. It's time to stop producing bad PDFs. By bad PDFs, I mean unstructured PDFs, not without tags. That is dying industry, I believe. It's time also to give author the full control over what his consumer will see, what or how his customer will consume his own content. Right now we have so many tools that do decision based on their own decisions. They do heuristics when extracting selection, when you do selection and you extract content. those tools are doing their own decisions, and that is something what goes against authors' will, we believe. And these provisions, these ideas, will give the full control over this process to author again. And well, yeah, the last sentence, instead of saying there is only one way to interpret PDF, that's been the highlight or something what we relied on for so many years, we will simply be saying that there is always a deterministic way of interpreting PDF content in a PDF. And that would be it. Thank you very much. And if there are any questions, I'm happy to answer those. Yep.
Just a little detail, these roles which you tag onto an element, can you have more than one role? I can see how that could be accomplished, but the need is probably there to have several roles, possibly.
Well, current language. Let me go back. There we are. Current description in PDF 2.0 says that you might have your own language, but for example, this comment text could point to something what is not of a standard type. But at the end, if you circle through all these mappings, you have to end up on a standard structure element type. And they are precisely described in a PDF 2.0. So one tag could only have one role. But that's the language you can use. When it comes to attributes, that's different. As I showed here, you may have different attributes on a tag. Yes?
How will a reader prioritize between conflicting class maps?
The same way as it does right now if you write your own HTML file. This is an algorithm that describes how you derive a PDF into an HTML. So if you say that you want to use a class map on a specific type of attribute, and then you override it as well somewhere, or you use style sheet, and then you override it with your attributes on a specific tag, then the derivation algorithm will write it in a specific order as it goes. And how does that HTML processor interprets it? It's on him. We are producing HTML files, and browsers are dealing with it. That's the same way as you would do that manually.
Yeah, so it's on the browser to write it properly.
Yeah.
Okay.
Any other questions? If not, I thank you. Yes. Go ahead.
Last question.
Yeah.
Do you know who's already working on derivation algorithms?
It's work in progress. The whole specification is not final yet, right? And so it's kind of hard to say that someone does have the derivation algorithm. Examples I showed you here are based on my implementation. I'm participating in TWG, and for my own purposes, I just write my own derivation algorithm. And not just for my own purposes. Tomorrow on Wednesday we are also running a hackathon here, and there is a couple of people from you guys participating in that, and we just prepared a couple of those tools for this hackathon so we can play with it. We can really see where the problems are when we craft our PDF files properly or in a bad way. We need to know under which circumstances this might go wrong. So we're trying. This particular example is my own. I can share it with anyone who wants it. It's not final. I don't really think it could be final until the specification is actually out. And also, I believe the big players would simply keep an eye on this, on the specification, and would be developing their own derivation algorithms in their own products or services. So that's my belief. Yeah. Thank you.
Thank you.